While you are sitting here listening to these words, something eerie is taking place across the cosmic dark. Far out in deep space, massive cities of billions of suns are suddenly freezing to death, and invisible monsters crawling through their glowing spirals and choking off their very breath. Star factories that should run for trillions of years are turning into silent, cosmic ghost towns right before our eyes. If you want to dive deep into real space mysteries without any clickbait or fake drama, hit that subscribe button right now. Subscribing ensures you never miss our daily journeys into the most terrifying secrets of the cosmos. Join thousands of fellow stargazers who love uncovering the raw truth about our universe. To understand why a galaxy dies, we first have to step back and look at how a galaxy stays alive in the first place. Every healthy galaxy in the universe acts like a massive cosmic factory, building new stars out of raw floating gas and dust. Deep inside giant dark clouds, gravity slowly pulls cold hydrogen gas closer and closer together until it gets so packed and hot that nuclear fire ignites. That spark creates a brand new star, giving off heat and light that brightens up the surrounding darkness. For almost a century, astronomers believed galaxies were virtually immortal machines that would keep pumping out stars for hundreds of billions of years. They thought a galaxy would slowly and peacefully use up its hydrogen gas supply over vast stretches of cosmic time. In this old view, a galaxy was supposed to fade away gently, like an old campfire burning down to soft, glowing embers over a very long night. Early computer models suggested that as long as hydrogen gas existed, gravity would keep pulling it in to forge fresh generations of suns. When scientists built powerful telescopes to look deep into the cosmos, they expected to see every galaxy overflowing with bright young stars. Young stars are extremely large, burning hot, and glow with a brilliant blue light that can be seen across billions of light years. Because these blue giant stars live short lives, finding them in a galaxy proves that the star factory is open and actively working. If a galaxy is healthy and functioning properly, its spiral arms should always be shimmering with these magnificent blue engines of light. Instead of finding vibrant star factories wherever they looked, astronomers bumped into a creepy wall across the sky. They discovered millions of huge galaxies that were completely dead, containing virtually no young blue stars at all. These systems were packed with nothing except tiny, old, fading red stars that had been floating around for billions of years without any new companions joining them. Astronomers began calling these eerie space objects red and dead galaxies. This discovery created a massive puzzle that stumped the best minds in science for several decades. Why would a galaxy with enough raw material to build billions of new suns suddenly shut down its assembly line? Where did all the cold hydrogen gas go, or why was it refusing to pull itself together under the force of gravity? The mystery became even stranger when advanced radio telescopes proved that many of these dead galaxies were still sitting inside massive clouds of hydrogen gas. Think about how bizarre that really is for a second. Imagine walking up to a giant iron furnace that is completely cold and dark, even though the room around it is filled to the ceiling with dry firewood. The fuel is sitting right there, touching the furnace, but no fire will start. Something in deep space was actively preventing the gas from cooling down and collapsing into stars, but nobody knew what kind of force could pull off such an impossible feat. Did you know that galaxies can hold onto massive clouds of gas without making a single new star for billions of years? Drop a quick comment right now and let me know if you have ever heard of these dead red galaxies before. If this weird space mystery is already blowing your mind, hit the like button to help more space fans find this story. To solve this cosmic riddle, scientists had to peer directly into the dark hearts of these frozen galaxies. At the exact center of almost every large galaxy sits a supermassive black hole, an anchor weighing millions or even billions of times more than our sun. For decades, astronomers assumed these central black holes were quiet, lazy monsters that just sat in the middle of space and swallowed whatever drifted too close to their mouths. They expected a black hole to affect only its immediate surroundings, controlling a tiny patch of space just a few light years across. Because a black hole is tiny compared to the total size of an entire galaxy, nobody believed it could dictate the fate of stars located millions of light years away. It seemed logically impossible for a single point of gravity in the center to turn off an entire galaxy. What researchers actually found completely shattered that old way of thinking. When huge amounts of gas fall toward a supermassive black hole, not all of it gets swallowed right away. Instead, the gas gets trapped in a spinning disk around the black hole, whirling around at nearly the speed of light. The friction and pressure heat this spinning gas up to millions of degrees, creating a super bright engine known as an active galactic nucleus. This central engine acts like a cosmic volcano, blasting out powerful beams of radiation and super-fast winds that roar through the entire galaxy. These winds move at thousands of miles per second, slamming into the clouds of cold hydrogen gas that the galaxy needs to build new stars. When the cold gas gets hit by these blazing hot winds, it gets heated up rapidly, or kicked straight out into the void between galaxies. Here is the key detail that most people remember once they hear it. Stars cannot form out of hot gas. For gravity to pull gas together into a solid new star, that gas must be extremely cold, dropping down close to absolute zero so the atoms slow down and fall together. The instant a supermassive black hole heats the gas up, the atoms bounce around wildly, fighting against gravity and stopping star birth in its tracks. For a long time, scientists thought this violent process was a single massive explosion that blew away all the gas in one giant burst. They pictured a single galactic blast sweeping the galaxy clean of star fuel over a few million years. While that sounded like an awesome movie scene, recent high-tech telescope data revealed that the truth is much more sneaky and terrifying. In early 2026, astronomers using the James Webb Space Telescope and the ALMA radio array focused on an ancient galaxy called GS 10578, which scientists nickname Pablo's Galaxy. This system sits over 11 billion light years away from Earth, meaning we are looking at it as it appeared when our universe was only 3 billion years old. Back in that ancient epoch, the cosmos was experiencing a massive baby boom, with most galaxies churning out new stars at record-breaking speeds. Yet when astronomers carefully measured Pablo's Galaxy, they were shocked to discover that it was already completely dead. It had managed to build up a total mass equal to 200 billion suns in just a short time, and then its star factory suddenly choked to a dead stop. When researchers swept the system searching for cold hydrogen gas, they found virtually nothing left to burn. Instead of finding evidence of a single huge bomb going off, the telescope data showed a slow, painful process called death by 1,000 cuts. The monster black hole at the core was continuously blowing out heavy winds of neutral gas moving at 400 kilometers per second. Every single year, these winds were driving out 60 times the mass of our sun in raw gas, slowly starving the host galaxy over tens of millions of years. The central black hole was not destroying the galaxy in one quick blast. It was repeatedly heating and shoving the gas every single time fresh fuel tried to settle back down. It acted like a ruthless cosmic guard standing at the front door, refusing to let any cold fuel sit still long enough to build a star. The entire galaxy was throttled by its own central monster, trapped in a state of permanent starvation. How incredible is it that a central black hole can slowly starve an entire galaxy from the inside out over millions of years? What do you think would happen to our own night sky if the Milky Way suddenly lost its ability to make new stars today? Type your thoughts in the comment section below and make sure to subscribe so you never miss a new discovery. While supermassive black holes murder galaxies from the inside, there is another terrifying killer lurking out on the open cosmic road. Galaxies do not float through deep space in total isolation. They are often pulled together by gravity into giant groups called galaxy clusters. A single galaxy cluster can hold hundreds or even thousands of individual galaxies, all tumbling through space together in a dense cosmic city. Scientists originally expected that living inside a crowded cluster would help galaxies grow much bigger and stronger over time. They reasoned that being close to other systems would provide a rich supply of extra gas and raw materials that galaxies could share or steal from each other, helping them build even more stars. On paper, living in a busy cosmic neighborhood seemed like the ultimate way for a galaxy to thrive. The real environment inside a galaxy cluster turned out to be a violent nightmare. The space between galaxies in a cluster is not empty. It is filled with a thin, super-hot mist of energetic particles known as the intracluster medium. This floating gas is heated by intense gravitational pressure to tens of millions of degrees, creating a thick atmosphere that moving galaxies must plow through as they orbit the cluster center. When a healthy, star-forming galaxy falls into a dense cluster, it travels at millions of miles per hour through this super-hot, invisible gas mist. As the galaxy races forward at extreme speed, it experiences a powerful dragging force called ram pressure stripping. You can easily picture this effect by imagining holding your hand out the window of a car moving down the highway at high speed, feeling the heavy air pushing back against your skin. Now imagine that wind is so insanely powerful that it blows your clothes, your shoes, and everything in your pocket straight off your body. That is precisely what ram pressure stripping does to an innocent galaxy moving through a cluster. The heavy, tightly packed stars inside the galaxy are far too dense to be bothered by the gas wind, so they keep moving forward without missing a beat. But the loose, fluffy clouds of cold hydrogen gas get caught in the wind and ripped completely out of the galaxy. As the galaxy speeds through the cluster atmosphere, it leaves behind long, glowing ribbons of stolen gas trailing millions of light years across the dark void. Astronomers call these stripped systems jellyfish galaxies because the long, thin tails of lost gas look just like glowing tentacles floating in a dark cosmic ocean. Once that cold gas is dragged away into the cluster, the galaxy loses its lifeblood and can never build another star again. A dramatic example of this cosmic tragedy is taking place right now inside the Virgo cluster, a massive collection of over 1,500 galaxies located 54 million light-years away from Earth. Space telescopes pointed at the Virgo cluster have snapped images of dozens of spiral galaxies in the exact middle of being stripped completely naked. Their bright spiral arms are slowly fading away as their precious star fuel gets ripped out into the hot cluster void. This proves that a galaxy can be completely healthy, rich in fuel and full of potential, only to be murdered simply by wandering into the wrong neighborhood. The environment around a galaxy can act like a giant vacuum cleaner, sucking away its future before a single new sun can ignite. It is a harsh reminder that deep space is a brutal landscape, where location determines whether you survive or freeze. If you had to guess, do you think our own Milky Way will ever suffer the same fate as those jellyfish galaxies in the Virgo cluster? Put your best guess in the comments right now and see how many other viewers agree with your idea. If you are enjoying learning about these hidden cosmic forces, take 2 seconds to smash the like button. Even if a galaxy avoids a hungry central black hole and stays far away from crowded clusters, it can still fall victim to a silent killer known as cosmic strangulation. To understand this subtle threat, we have to look at the massive unseen framework that supports every single galaxy in the universe, dark matter. Scientists used to believe that galaxies enjoyed an endless, uninterrupted supply of fresh hydrogen gas flowing in from the cosmic web. The cosmic web is a giant network of invisible dark matter threads that stretches across the entire universe, acting like a cosmic highway system for raw fuel. Fresh, cold gas was supposed to slide smoothly along these dark highways and drop directly into galaxies, keeping their star factories burning forever. The big surprise came when researchers carefully measured the temperature of the dark matter halos surrounding large, mature galaxies. Every galaxy sits right in the middle of a giant, invisible ball of dark matter called a halo. As a galaxy grows larger and accumulates more mass, its gravitational pull becomes insanely powerful. When fresh gas from the cosmic web attempts to fall down into a heavy galaxy, it falls so fast that it hits a wall of thermal pressure. This violent collision triggers a process called shock heating. The incoming gas crashes into the galaxy dark matter halo at supersonic speeds, instantly converting all its motion energy into extreme heat. Instead of falling smoothly into the galaxy as cold, usable fuel, the incoming gas gets cooked up to over 1,000,000 degrees Celsius in a flash. Remember the fundamental rule of star creation. Gas must be cold to collapse into stars. Because the incoming gas becomes super hot upon arrival, it gets trapped in the outer halo and cannot cool down enough to sink into the main disk where stars are built. The galaxy ends up completely surrounded by trillions of tons of hydrogen gas, but none of it can actually make its way onto the factory floor. The galaxy is effectively choked off from its supply lines, stranded right in the middle of a giant hot gas bubble. It continues using up whatever cold gas it already has stored inside its disk, building new stars as fast as it can. But because no fresh gas can get inside to replace what was burned, the internal fuel tank eventually runs completely dry. Once that internal supply is completely exhausted, the star formation engine shuts off forever. Astronomers call this death by strangulation because the galaxy is slowly suffocated as its life support is cut off from the outside world. It does not get destroyed in a big explosion. It simply uses up its last breath and goes dark, leaving behind a cold shell of aging red stars. This brings us to a mind-bending realization that changed astrophysics forever. A galaxy can kill itself simply by growing too big. Once a galaxy crosses a critical weight threshold, roughly 1 trillion times the mass of our Sun, its own gravity becomes its worst enemy. Its dark matter halo gets so heavy that shock heating kicks in automatically, shutting off its fresh gas supply forever. Which of these galactic killers sounds the most terrifying to you? Central black hole winds, the ram pressure windstorm, or cosmic strangulation? Drop your pick down in the comments section below. If you want to keep exploring these mind-blowing space facts with us, make sure you hit that subscribe button right now. There is one more dramatic way a galaxy can meet its end, and this path involves a massive cosmic collision. Across the vast distances of space, galaxies are constantly pulled toward one another by gravity, slowly dancing closer over billions of years until they crash together in giant galactic mergers. For a long time, people assumed that when two galaxies crash, thousands of stars would smash directly into each other and destroy everything. They imagined a chaotic explosion of stellar destruction that would tear both galaxies to tiny pieces in an instant. It sounded like a complete catastrophe that would wipe out entire solar systems without warning. In truth, stars are so far apart from each other that when two galaxies collide, almost no stars ever actually hit one another. Instead, the real drama takes place within the giant gas clouds scattered throughout both systems. As the two massive galaxies pass through each other, their gas clouds slam together at high speeds, creating intense shock waves that compress the hydrogen gas rapidly. This compression triggers a sudden, violent event known as a starburst. For a short period of cosmic time, the merging galaxy starts producing new stars at an insane rate, hundreds of times faster than normal. Millions of brilliant new suns ignite all at once, lighting up the dark sky in a breathtaking display of cosmic fireworks. However, this dazzling burst of life comes at a fatal cost to the galaxy. By burning through its fuel at such an extreme speed, the galaxy uses up almost its entire gas supply in a tiny fraction of its normal lifespan. At the exact same time, the merger feeds massive streams of gas directly into the central supermassive black holes, waking them up and unleashing giant jets of energy. The combination of the starburst consuming the fuel and the active black holes blowing away the rest leaves the newly merged galaxy completely empty. In just a few 100 million years, the vibrant starburst dies down, leaving behind a smooth, featureless, ball-shaped elliptical galaxy. The merger gives the system one final, incredible party before plunging it into permanent silence. In order to truly understand the sheer scope of this process, scientists have begun building complex supercomputer simulations that map out the entire life cycle of these merging systems over billions of cosmic years. These advanced computer programs allow astrophysicists to fast forward through time and watch as billions of simulated gas clouds interact, compress, heat up, and get blasted out into deep space. What these high-tech simulations reveal is that galactic death is not a rare accident, but an inevitable milestone in the evolution of almost every massive structure in our universe. As the universe continues to expand and age, galaxies naturally clump together, grow larger, feed their central black holes, and eventually shut down their internal engines one by one. The universe is actively transitioning from a wild, energetic youth filled with vibrant star creation into a quiet, middle-aged period where star production is dropping off dramatically everywhere we look. Right now, scientists estimate that the overall rate of star formation across the entire universe is less than 10% of what it was during its peak cosmic noon period roughly 10 billion years ago. We are literally residing in a cosmos that has already passed its prime energy output, steadily sliding toward a much quieter and darker future. Every passing billion years sees fewer new suns being born than the billion years before it, marking a clear direction toward long-term exhaustion. Now, shift your perspective from distant galaxies to our very own neighborhood right here in space. This is not just a story about far-off objects billions of light years away. This is the literal future of our own galaxy, the Milky Way. Right now, our galaxy is a healthy, active star factory, producing about 1 to 2 new suns every single year. Our night sky is filled with bright blue stars and massive dark clouds of gas where new solar systems are actively forming. But scientists looking closely at our local environment have noticed that the Milky Way is already starting to slow down its production. The rate at which our galaxy builds new stars is only a fraction of what it was 8 billion years ago, showing early signs that the cosmic engine is gradually tiring out. Even more importantly, we are currently on a direct collision course with our giant neighboring galaxy, Andromeda. Andromeda is rushing toward us at roughly 110 kilometers per second, or about 250,000 miles per hour. In about 4 billion years, the Milky Way and Andromeda will slam into each other in a colossal galactic merger that will reshape our region of space forever. When that happens, our two beautiful spiral galaxies will combine to form a single giant elliptical galaxy, which scientists often call Milkomeda. The collision will trigger a massive starburst, lighting up our night sky with billions of short-lived, brilliant new stars. Nighttime on Earth, if anything is still around to look up, will be bright enough to read a book under the glow of the merging cores. Once that starburst finishes consuming the cold hydrogen gas, and once the combined supermassive black holes blast away the remaining debris, the newly formed Milkomeda galaxy will shut down star formation for good. Our home will join the ranks of the red and dead galaxies, floating quietly through space as its remaining red dwarf stars slowly burn out over trillions of years. When you look up at the night sky, you are looking at a universe that is slowly, steadily running out of light. Every time a galaxy stops making stars, another light bulb in the cosmic house gets permanently unscrewed. Billions of years from now, star formation across the entire universe will drop to absolute zero, leaving behind a dark, quiet cosmos filled only with fading stellar remnants and quiet black holes. Human beings are living during a golden era of the universe, a brief epoch when galaxies are still alive, glowing and creating fresh solar systems like our own. The fact that we exist right now to witness these grand cosmic cycles makes our small place in space feel infinitely more special and rare. Understanding how galaxies die helps us truly appreciate the fragile spark of life we enjoy on Earth today. If you loved this deep dive into the dark forces that kill galaxies, please hit the subscribe button right now and turn on all notifications so you never miss an upload. Drop a comment below telling me, do you think humanity will ever find a way to travel to another galaxy before our own Milky Way goes quiet? Share this video with a friend or family member who loves space mysteries, and thank you so much for watching today.